Hello everyone, today I'm at the Canada Agriculture and Food Museum in Ottawa, Ontario, Canada. I'm going to take you on a tour. Let's go check it out. All right, so this is the map of the farm that we can explore. I'm going to start here, and then it basically is a loop of different barns and exhibits. So let's go check it out. All right, so first we are starting at the horse and cattle barn. So in here there is a bunch of horses. That you can get a good look at. And this is a fun display of showing how the height of a horse is calculated by hands. So how to measure horses. Horses are measured from the withers, shoulders down to the ground. So one hand is 10 centimeters. And then you can calculate how many hands your height is with this. Okay, so horses were a big part of everyday life in Canada throughout the 20th century. They were put to work in agriculture, forestry, and mining, as well as in cities. In 1919, there were 3.4 million horses on farms alone. What kind of work did these horses do? They transported people and goods, pulled and powered equipment, and herded cattle. So today, machines do most of the jobs that horses did in the past. Canada is now home to around 500,000 horses, though there are still some work horses. Most are kept for recreation or for competitive sports. All right, so let's keep exploring the barn. So this horse's name is Celtic, and he is a Hanoverian. And here we've got a Newfoundland pony. So in the 17th century, British settlers brought ponies with them to Newfoundland. Breeds including the Exmoor, Dartmoor, New Forest, Highland, and Connemara were allowed to roam free and breed. The Newfoundland pony is the result of these breeds mixing and adapting to the climate. In the past, this breed of ponies played an essential role in everyday life. They were put to work in a range of industries and were known for having a good temperament. The island alone was home to an estimated 12,000 Newfoundland ponies by the 1960s. Right, so let's see. Oh, he is having a nap. Here's a pony having a nap. He looks very relaxed. Here's a bunch of saddles and bridles. I don't know if you can see, but in here there are some chickens. Go sign is white leghorn chickens. Oh, look at these cute little babies. Hard to see the ones that are in this corner, but there's 3 of them in there. Oh, here is a very large cow just chilling. Oh, so her name is Lady and an Angus cow. Okay, there's more animals on the other side. Let's go check them out. Oh, so here you can see them. There's a mom and baby cow. There's some information on the baby. Oh, we've got some birds in here. So they're turkey. Not sure if you can see them. Oh, turkey. Right, so just outside the barn, there are some more animals. So here are some donkeys. Oh, this one looks like he's about to either nap or take a roll. How cute are they? And over here, there's some cows. All right, now we're gonna go check out the small animal farm, which is directly across. Oh, maybe you can get a better view of the donkey from over here. How funny is he taking a little nap? Hi, buddy. Are you taking a nap? I can see your teeth. And this little guy. All right, let's head into the small animal barn. Here is a goat. Oh, and here's a lamb. There's 2 lambs in here. Looks like a lot of them are having their afternoon nap. Here's some more ones that are a little more awake. Hi, little buddy. Oh, you guys are really awake. Hi. I wish I had food for you. Look at this goat. He seems to be having a nap in his hay bin. Hi. Look, this one is just full on saying hello. Hi. Look at this cute little baby lamb having a little nap. So cute. Oh my goodness. Here are some rabbits. There's one in the crate and there's another one having a snack. Over here, some more lambs. There's another one here in the corner. There's some goats. These guys are hungry. All right, next we're gonna go check out, there's some more, oh, hang on, just noticed, there's some animals here. Oh, so they are some chickens, I believe. Hopefully you can see them. I like the white one. All right, so there's a bunch of other outdoor animals on the side of this building. So right here, there's a bunch more. Cute, they've got a little ramp for them to play on. So here's one that's just staring at me, chilling on the ground. Hi, buddy. And then if you can see, there's a couple of them standing on top here. This guy's still staring at me. Oh. Goat just laid down. Okay. We move along. There's some more over here. We've got some llamas and sheep. Oh, so this llama is lying down. He's pretty cute. Oh, we've got one sheep right here. Hi, buddy. Hi. I don't have any food. I'm sorry. And what does this say here? The three Arcot breeds, the Rito, the Canadian, and the Outaouais, were developed here on the Central Experimental Farm. They were named after the Animal Research Center in Ottawa. The Rito and the Canadian are among Canada's most popular sheep breeds today. Right. So there is, hopefully you can see them. There's a whole bunch of sheep and one llama. They're all hanging out in the shade here. Right, so the sign says, people often confuse alpacas and llamas, which are both camelids. Here are some ways to tell them apart. You may also be able to tell a llama from an alpaca by how it is being used. Both are raised for their fleece, but llamas can also carry packs and pull carts. Farmers sometimes keep llamas to guard sheep from predators such as coyotes and foxes. Okay, so that just shows their varying heights and weights. Alpacas have a low set tail, llamas have a high set tail. Alpacas have a single coat, llamas have a double coat, and they have different shaped ears. An alpaca has a spear shaped ears, and a llama has banana shaped ears. Interesting. So alpacas, originally from the Andean highlands in South America, alpacas arrive in Canada in the late 1980s. On Canadian farms, alpacas are usually raised for their fleece and are shorn once a year. They are also used in agri-tourism. All right, well, let's move on to the next attraction. Right, so right in front of me, you can see an interesting, it's like an outline of a barn, and they've set up benches and tables where you can hang out and have lunch. But there is a special story about this, which I'm going to show you right now. So, this pavilion is dedicated to the memory of the animals in barn lost to the fire of 1996. A barn built in 1906 originally stood on this site. It housed the Central Experimental Farm's workhorses and later a showcase beef herd. As part of the museum, the barn was home to a variety of animals, large and small. In 1996, the barn and a neighboring house burnt to the ground. Tragically, many animals died in the fire. This skeletal structure is the exact shape and size of the original barn. It offers shelter for picnics and special events. right. So next, we are headed into the learning center. So, the Engineering Research Building was constructed in 1936 to 1937, replacing a number of smaller buildings, including a tobacco drying shed. Engineers in this building tested and customized farm machinery as well as building materials and methods. In 2013, the Engineering Research Building was renovated to update its interior while preserving important heritage details and character. All right, let's go inside and check it out. Okay, so this is the entryway with a bunch of different interesting displays that you can come and read. But I'm just going to head straight to the exhibition. So this is an interesting story about this bell. So for over 90 years, this bell hung in a tower at the top of the original beef cattle barn. In its earliest years, it was rung at noon each summer day to call in the field workers for lunch. During the fire that destroyed the barn in August 1996, the bell tower collapsed and the bell fell to the ground. Several farm workers searched through the charred remains until they found the bell. Although it was cracked from the intense heat and will never ring again, the bell is a vivid reminder of the rich history of this central experimental farm. You can see it says farm. And on the other side, experimental. So experimental farm, written right on the bell. Neat piece of history. So aquaculture is the farming of fish, shellfish, and seaweed in oceans, lakes, and on land. An important source of food. Aquaculture creates jobs and supports local communities. Aquaculture is at a crossroads. Can we produce more food from our waters, fight climate change, and protect people's livelihoods? Yes, we can. Find out how Canadians are inventing new methods to do just that. Aquaculture isn't new. In fact, it's ancient. But it has changed and grown so much over time that the world now gets more seafood from aquaculture than from the wild. In Canada, however, most of our seafood still comes from fishing. With aquaculture farms on the east and west coasts and everywhere in between, this may soon change. For that to happen sustainably, the industry needs to grow in ways that preserve the environment and our communities. So the Indigenous people were the first to practice aquaculture. They used traditional knowledge to farm clams and other seafood. Governments began building fish hatcheries in the 1850s. Their goal was to restore overfished waters. Commercial shellfish farming began soon after. Aquaculture as a business took off in the 1980s and continues to grow today. So, the indigenous people have farmed shellfish for thousands of years. Today, farmers combine traditional techniques and new practices to grow shellfish in a sustainable way on the Atlantic and Pacific coasts. Mussels and oysters are the most valuable shellfish farmed in Canada. As the industry continues to grow, it generates revenue that supports coastal communities. Shellfish farming is good for the environment. Farms create habitats for other life, help clean the water, and capture carbon.
Meet a sound marker. Select the language to start.
So, what's so great about shellfish farms? They're good for the environment. Unlike other farm animals, mussels and oysters don't need to be fed. Instead, they filter their food from the water. This helps to clean the water by capturing excess nutrients. In addition, shellfish farms create habitats for other sea creatures.
Meet a sound marker. Select language to start. Meet an oyster farmer. Select language to start.
So, why farm shellfish? Because people like to eat them. Farming shellfish has its challenges, but because it requires few resources, it's possible for smaller farms to succeed, and you never have to feed oysters and mussels. Shellfish farms bring income to coastal communities. Not only that, but they are probably the most sustainable source of animal protein you can eat. So, what about other types of shellfish? Mussels and oysters are by far the most popular shellfish raised in Canada, but Canadian farmers also raise clams, scallops, and geoducks. Like mussels and oysters, these shellfish are still harvested in the wild. They are also raised sustainably on Canadian shellfish farms. So, giant scallop, manila clam, geoduck. So, this is a neat display. So, it's got the light on the floor. And then if you look up, there's a neat.
Meet a sound marker. Select the language to start.
So, aquaculture is at a crossroads. With our planet facing a climate crisis, we need to transform how we feed our growing populations. Researchers and producers have to keep developing new practices and better tools to produce enough sustainable seafood to feed us all. We have a role to play as well. Our shopping decisions will shape the future of aquaculture. We can add more fish, shellfish, and seaweed to our diet and choose local and Canadian products. Can seaweed help the environment? Yes, seaweed farms can benefit the environment. In fact, growing seaweed can help us fight climate change. Like plants, seaweeds capture carbon through photosynthesis. They are fast growing and don't require fertilizer, and they remove excess nutrients from the water. All these traits add up to a renewable food source that's good for us and good for our planet. So, seaweed are large plant-like forms of algae that live in water. They have been farmed for millennia in Asia, where the seaweed industry is very large. Seaweed farming has also taken hold in Canada. Farmers here are developing ways to grow seaweeds such as kelp and Irish moss. Climate change is already affecting our daily lives. Seaweed farming can be just what we need to reduce our environmental impact and build more resilient coastal communities.
Meet a kelp farmer. Select a language to start. I don't know where it was that. Meet and place your choices in select language to start.
What is sustainability? Something is sustainable if we can use it or do it for a long time without harming future generations. To be sustainable, aquaculture must protect the environment and support local communities. As climate change affects where and how we produce food, it is even more important to work together to develop solutions. All right. There are a few interesting historical items outside that I want to show you next. Right, so just outside this building are some historic walking plows. Sorry for the air conditioner noise. Right, so the walking plow is old technology dating back to ancient civilizations in the Middle East. Plows are used to break the ground and till the soil in preparation for planting crops. European settlers first brought plows and animals to pull them to North America in the 1600s. A farmer hitched one or more draught animals, a horse, mule, or ox, to the plow and walked behind it, steering the plow through a field. Here's a picture. All right, so there's one other display over here I want to show you. The seed drill. Seed drills like this gave farmers control over the placement of seeds during planting. Furrow openers created soil channels the appropriate depth and distance apart, into which the machine dropping seeds. Some drills included attachments to cover the seeds from soil. Many historians credit agricultural innovator Jethro Tull with developing an early version of the modern seed drill in England during the 1700s. And here is another picture. So this is a farmer seeding a crop with a seed drill around 1927. Okay, so there is a little garden here. So home sweet home, many different critters visit and live in our garden. Some are helpful while others cause harm. Can you tell the friends from the foes? Parasitic wasps, Japanese beetles, hoverflies, and the orb weaver spider. Right, so we're going to check out the Eco Explorium. Sign, the Eco Explorium. It's just a small little display in here. So welcome to the Eco Explorium. Plants and invertebrates, which we often call bugs, depend on each other. Bugs help pollinate plants and spread their seeds, and they break down dead matter into nutrients that plants need for growth. Meanwhile, plants provide food and homes for bugs. Understanding and encouraging the relationship between these living things can make us better gardeners and farmers. More of these natural interactions mean less need for fertilizers and pesticides that can harm the environment. Okay. Plants 101. Roots, stems, leaves, and flowers all have important roles to play in the plant's life cycle. But plants come in all shapes and sizes. By evolving into different shapes, plants have adapted to the different growing conditions and environments found around the world. They also have their own unique interactions around them. Did you know humans began domesticating plants around 12,000 years ago? We can thank our ancestors for the food crops we eat today. In Canada, greenhouses allow us to grow food year-round. Despite our long winters, we grow most of our grocery store tomatoes, cucumbers, and peppers inside greenhouses. In most greenhouses, plants don't grow in soil. Instead, they grow in small amounts of soil-less growing medium with their roots soaked in nutrient-rich water. This method is called hydroponics. Inside greenhouses, growers bring bugs and plants back together. When plant-eating bugs find their way inside greenhouses, they can quickly multiply and cause a lot of damage. So, some growers fight bugs with bugs. They release tiny helpful predators that eat the unwanted guests. Inside greenhouses, flowering plants such as tomatoes and eggplants still need pollinators to make fruit. Releasing bumblebees inside the greenhouse can help. They bring pollen from one flower to another, allowing the fruit to start growing. Back outside, we find many kinds of pollinators, and they include over 800 different kinds of native bees. Each type of bee is special in its own way and may have a type of flower and habitat they prefer. Meet the honeybees. Honeybees live in a group called a colony. The colony is made up of one queen, a few dozen drones, and thousands of worker bees. So this is neat. You can actually see the bees. And here, it's a huge display of them. Closer. All right, now we're going to explore the Sustainable Agricultural Gallery. And just so you know, over here is where the demonstration kitchen is. So what are farmers and agricultural business owners saying about environmental sustainability? These quotes come from Agriculture and Agri-Food, Canada's Taste the Commitment video and story series. I think the number one thing we set out to do was to grow food closer to where people live and grow it more sustainably. I'm part of a new generation that is working on sustainable changes, improving the local food system, but you know we build everything on the shoulders of giants. We're always thinking about ways to be efficient while also being environmentally responsible. So in the 20th century, tile drainage was more common in Ontario, Quebec, and parts of British Columbia than in the rest of Canada. In recent years, more prairie farmers have been using tile drainage. It helps them adapt to more severe and unpredictable rainfall. Modern drainage technology also contributes to the popularity of tile drainage. Drainage tiles are made of plastic pipes, and ditchers can dig trenches and lay tile on at the same time, making the process faster and more accurate. Okay, so here is an example. So plastic drainage tile. Most modern drainage systems use plastic pipes as tile. Water from the surrounding soil enters the tile through small holes. Fabric around the tile allows water through but stops soil from clogging the holes. This tile can be laid by the same machine that digs the trenches. Okay, so this, you can see, this is the drainage tile. Pollution and drainage. When water leaves the farmer's fields, it can carry soil nutrients into rivers and lakes. These nutrients include nitrogen and phosphorus, key fertilizer components. They can affect water quality and lead to eutrophication. Farmers follow rules and best practices to limit nutrition loss. So that is a tile maker, the 1910s, made by Cement Tile Machine Company, artifact number 1977.0637. This machine was used to make cement tiles, an alternative to clay tiles. So trenches were initially dug by hand. Later, people could dig trenches deeper and faster with specialized machines. Horses powered these first ditching machines. Steam and diesel-powered ditchers were introduced in the early 1900s. Tile was still laid by hand. And here's an example. Workers in the St. Lawrence lowlands, Quebec, lay tile by hand as the ditching machine digs a trench late 1950s. So drainage tile samples. Until the 1960s, most tiles were made of clay or cement and were still laid by hand. Okay, so there is a giant screen here with seats, so you can come and sit here and watch a documentary to learn more. Dyes from locally grown plants. The Pembina Fabriche encouraged people to use dyes from plants that can be grown and harvested in the region. The group offers workshops on natural dyeing. It experiments with local color on local wool. Selling wool directly to users. Regional wool producers and mills usually sell directly to local makers. Makers connect with producers online at their farms and at fiber festivals. The Fibrecht values community. Producers developed lasting relationships with the people who use their wool. Producers sell not only raw wool and yarn, but also value-added wool products. The Fiber Shed has created labels to identify goods made completely in southern Manitoba. Sheep for wool. Most sheep farms in Manitoba raise the animals for meat. At these farms, wool is often thrown away. There is a limited market for these fleeces, but there are some small-scale sheep producers who focus on fiber for textiles. They raise breeds with long or fine wool. Farmers also rear other animals such as goats, alpacas, and rabbits for fiber. Some people produce small amounts of plant fiber such as flax for linen. Sheep shearing. Most sheep do not shed while they are sheared once a year for their health. Removing the fleece means that people can use it. Shearing calls for a lot of skill, and it must be done by hand. With a limited number of shearers in Manitoba, it can be difficult for small producers to find one. Processing wool into yarn. Wool for textiles is often transformed into yarn. Some artisans do this by hand, but hand processing is not practical on a large scale. On an industrial scale, wool is transformed into yarn at mills, but Manitoba doesn't have many wool mills. Producers can wait over a year for their wool to be spun into yarn. The Pembina Fabriche promotes regional wool processing. It supports both artisanal and industrial yarn production. Fleece drying after being scourged at Longway Homestead's wool mill. A hand picker at Prairie Edge Wool Farm. And a hunter puts wool into the carding machine at Longway Homestead Wool Mill, and it comes out at roving So she puts it through. It can produce roving a thin rope-like bundle or batting a flat sheet. Barb Mullock's spinning wheels at Prairie Edge Wool Farm. The spinning machine at Long Way Homestead's Wool Mill. Right spinning pulls the fibers apart for creating a thinner roving and twists them to make the fibers stronger. Yarn is plied at Long Way Homestead's Wool Mill. Plying turns yarn back on itself and twists it together. This makes the yarn stronger. Right, and the last is a bit of kind of fun interactive part. So here's a fun little exhibit. It's like sitting on a tractor.
Select a language to start using the rectangular buttons on your left.
So you can sit here.
Aventure agricole.
I'll hit English.
You're about to embark on a farming adventure. Get ready to drive a tractor and use modern technologies to plant corn. To
And
continue,
I have a steering
press the
wheel.
next button, a triangle pointing to the right. To go back,
Next button.
today's tractors are equipped with modern technologies, including a global positioning system or GPS. These tools help farmers grow more food with fewer resources, making farming more efficient and sustainable. To continue, press next.
Next.
Your mission is to plant corn in the most efficient way possible. To do that, you must drive the tractor along the route set by the GPS. To continue, press next.
Next.
Try it. Use the steering wheel in front of you to steer the tractor and follow the route. The steering wheel vibrates when you drift off course.
Uh-oh.
This sound means that you're following the GPS route. To continue, press next.
Next.
Use the throttle handle to your right to control the speed of the tractor. Go ahead and push the handle forward to go faster.
Speed. Okay.
Now slow down.
Slow
Pull
down.
the handle down. To continue, press next.
Press
To
next.
protect soil health and reduce your carbon footprint, you're using a planter that creates rows in the soil and drops in seeds at the same time. To continue, press next.
Next.
You'll be guided to raise and lower the planter as you are making turns. You must lower the planter to plant corn. Try it out. The planter switch is on your right.
Here.
Raise the planter by flipping the switch up.
Up.
Now flip the switch down to lower the planter and plant the seed. To continue, press next.
All right. Press next.
Are you ready to start?
I am
To
ready.
Play without help. Play with help. To select this option, press start.
Start.
Get ready.
Oh,
Your
gosh.
adventure is about to begin.
Oh, speed.
That's it. Keep on driving straight ahead. You're moving at the speed of a turtle. Try going
It does
faster,
vibrate.
or you'll run out of time. Veer to the right.
Am I supposed to?
Slow down. You're
Oh.
coming to the edge of the
Slow
field.
down. Okay.
Raise the planter to stop planting. Make a U-turn to the left.
Okay. That shows me.
Stop turning and follow the GPS route.
Okay, this is kind of fun.
Lower the planter to start planting again.
Oh, I've lost control. Not easy to do with one hand.
You're moving at the speed of a turtle.
Uh-oh,
Try going
speed up.
faster, or you'll run out of time. Slow down. You're coming to the edge of the left. Make them count.
Uh-oh, I'm running out of time.
Raise the planter to stop planting. Time's up. Let's see how well you planted and
Not
what
very
kind of
good.
farmer you are.
A farmer in training.
Good job. As a farmer in training, you've managed to plant between 26 and 50% of the corn in the right place. Try to follow the GPS route more closely next time.
I have to work on my
You'll
farming
waste less
skills.
seed, increase your yield, and make better use of your land. You can do it. There's a farmer in you.
All right, there's a farmer in me. All right, so the last fun thing to do, there is a tractor. You can go in. I've never sat in a tractor before. Oh my goodness. Okay.
Choisissez une langue pour commencer en utilisant les
All right,
boutons rectangulaires.
English.
You're about to embark on a farming adventure. Get ready to drive a tractor and use modern technologies to plant corn. To continue, press the next button.
Next.
Today's tractors are equipped with modern technologies, including a global positioning system, or GPS. These tools help farmers grow more food with fewer resources, making farming more efficient and sustainable. To continue, press next.
Next.
Your mission is to plant corn in the most efficient way possible. To do that, you must drive the tractor along the route set by the GPS. To continue, press next.
Next.
Try it. Use the steering wheel in front of you to steer the tractor and follow the route. The steering wheel vibrates when you drift off course. This sound means that you're following the GPS route. To continue, press next.
Next.
Use the throttle handle to your right to control the speed of the tractor. Go ahead and push the handle forward to go faster. Now slow down. Hold the handle down. To continue, press next. To
Next.
protect soil health and reduce your carbon footprint, you're using a planter that creates rows in the soil and drops in seeds at the same time. To continue, press next.
Next.
You'll be guided to raise and lower the planter as you are making turns. You must lower the planter to plant corn. Try it out. The planter switch is on your right. Raise the planter by flipping the switch up. Now, flip the switch down to lower the planter and plant the seeds. To continue, press next.
Next.
Are you ready to start?
I
To
am.
play without help, press previous. Play with help.
Next.
To select this option, play with
Next.
help. To select this option, press start. Get ready.
All right.
Your adventure is about to begin.
Wish me luck.
That's it. Keep on driving straight ahead. You're moving at the speed of a turtle.
Uh-oh.
Try going faster, or you'll run out of time.
Okay, I think I'm doing better this time.
Slow down. You're coming to the edge of the field.
Uh-oh.
Raise the planter to stop planting.
Okay.
Make a U-turn to the left. Stop turning and follow the GPS route. Lower the planter to start planting again. You're moving at the speed of a turtle. Try going faster, or you'll run out of time. Slow down. You're coming to the edge of the field. Raise the planter to stop planting. Make a U-turn to the right.
All right, I think we did better this time.
Stop turning and follow the GPS route. Only 10 seconds left. Lower the planter to start planting again. Time's up. Let's see how well you planted and what kind of farmer you are.
Still a farmer in training.
Good job. As a farmer in training, you've managed to plant between 26 and 50% of the corn in the right place. Try to follow the GPS route more closely next time. You'll waste less seed, increase your yield, and make better use of your land.
All right, that was fun.
There's a farmer in
You definitely need to come check this out. All right, so that is the end of this section. Let's head to the next. All right, so Building 88 Federal Heritage Building. The main dairy barn was built in 1888 to test new techniques for milking, bedding, and feeding dairy cows. When the barn burnt down in 1913, it was quickly rebuilt the following year and remains an Ottawa landmark. This building is a bank barn design. Bank barns are built into slopes to give ground level access to both the upper and lower levels. So welcome to the dairy barn. Have you had a glass of milk today? That milk might have come from these cows. This barn houses the dairy cows and calves at the Canada Agriculture and Food Museum. It's part of a real dairy farm with its agricultural equipment, its daily chores, and of course, those familiar farm smells. So here are the cows. How much milk can a cow produce? It depends on her breed, her age, and how long she has a calf. On average, a Holstein cow produces 10,000 liters of milk a year. This amounts to 33 liters per day, or enough milk to fill 128 glasses. Say hello to the cows. Remember, you're not allowed to touch them. This guy's got an itch. So what are pasteurization and homogenization? Raw milk. So pasteurization. Raw milk may contain microorganisms that could make us sick. To destroy them, the dairy plant pasteurizes the milk. It's heated for 15 seconds between 72 degrees Celsius and 80 degrees Celsius and then cooled quickly. Homogenization prevents milk fat from separating and forming a top layer of cream. The process breaks down the large fat globules into smaller ones that remain distributed throughout the milk. Hello, cows. All right, so make sure you walk through because there's more information over here. It takes approximately 15 to 20 minutes for a farmer to milk a cow manually. A milking machine does it in about 3 minutes. In earlier days, cows were milked by hand into open pails. Today, all dairy farms in Canada use a milking system to milk cows and store the milk. Welcome to the calf barn. This barn is home to our young dairy cows called calves. Most of the calves you'll find in this barn are females or heifer calves. Males or bull calves are only here for a short amount of time. At a young age, we take them to a sale barn for auction. We separate dairy calves from their mothers within 24 hours of their birth, keeping the calves away from the older cows, including their mothers, reducing their risk of catching diseases. For the first 4 days, the calves live in pens on their own and are fed their mother's milk in a bottle. We do this to make sure the calves get enough milk. After that, we move them to the group pen and they get their milk from the automatic calf feeder. A growing calf is a hungry calf. Automatic calf feeders allow the calves to eat whenever they are hungry. So that's what it looks like. And here are a couple of baby calves. He's following me. I don't have any food, little buddy. You're super cute, though. You guys are really cute. Dry cows. These cows are taking a break from producing milk. We dry up, stop milking a cow 2 months before her calving date. During this period, the cow rests and focuses her energy on the calf that's rapidly growing inside her. All right. So there is a play area for the kids. And sometimes you can get beaver tails here when this is open. Here's another shot of the barn. And now we are going to go into Discovery Park. So, welcome to Discovery Park, a new discovery every season. Agriculture is a dynamic industry, constantly transforming by human ingenuity and creativity. Explore some fascinating agricultural innovations in this interactive park. You may be surprised what you find. All right, let's explore. So, there is a nice gazebo on the left. So, a calf's first home. A first home, so calves are born with a weak immune system and can get very sick for the first 2 months of their lives. To keep the calf healthy, dairy farmers usually house them away from older animals and the germs they carry. Many dairy farmers house their calves outdoors in individual hutches like this. So there's an example of one right here. I'll show you it more in a minute. The hutches have everything a calf needs to be healthy and comfortable. And here's a picture. And this is what it looks like in real life. This is what it looks like inside. All right, let's keep exploring this park. Guess which animals can work the pump? Okay, so you have a picture of a cow, and the answer is yes. The answer is yes. A horse. The answer is yes and no. A sheep. The answer is no. Just like us, farm animals need clean water. Getting water to animals in far off pastures or during the winter months can be challenging, as it takes energy to pump water and to keep it from freezing in cold weather. Developed by a farmer in Alberta, the frost-free nose pipe is a waterer that allows farm animals to pump the water they need in both summer and winter. Here's a picture of real animals. Here's a diagram of what it looks like. Right, so the native garden. Welcome to our natural garden. All the plants that grow here are native to Canada. Gardens like this are important. They give native bees, butterflies, and other pollinators food and a place to live. In return, pollinators carry pollen from flower to flower, helping the plants to set seeds, Because they have evolved together, native plants and pollinators have a special relationship. They need one another to survive and thrive. So pollination allows plants to reproduce. It is the transfer of pollen from the male part of the flower, the stamen, to the female part, the pistil. Some plants, such as the ones in this garden, need pollinators to carry their pollen. Others rely on wind or water. So pollinators feed on the pollen and nectar of flowers because they bloom at different times. The plants in this garden feed pollinators from spring through fall. So, monarch butterflies lay their eggs on milkweed plants. Their caterpillars feed only on the leaves of this native plant. Know your pollinators. These native pollinators often visit our garden. To these, let's see. Oh, they do open. Okay, so a bumblebee. This social bee is a great pollinator as it forages the bee buzzes. This causes a vibration that releases more pollen from flowers. Oh, I didn't know that. The painted lady butterfly. This butterfly migrates south during our cold winters. It can fly at speeds of almost 500 kilometers per hour. The miner bee. This small bee builds its nest in the ground. It lives alone and doesn't usually sting. Bald-faced hornet. We may not like the bald-faced hornet because it can sting, but it also eats harmful insects and helps pollinate. So, native pollinators are at risk. Habitat loss, pesticide use, and climate change are contributing to their decline, but we can help by growing native plants in our gardens, on our balconies, at school, and in community gardens. We can give native pollinators the food and shelter they need. So how we tend our gardens can make a difference. Leave some bare patches of soil for pollinators that nest in the ground. Don't remove stems from dead plants and leave twigs and branches on the ground. Certain pollinators will nest in them. I did not know that. The Fletcher Wildlife Garden here in Ottawa is home to many native pollinators. Honeybees are not native to Canada. They are introduced by Europeans for their delicious honey and to pollinate crops. Potatoes in Canada. In Canada, potatoes are the 5th largest agricultural crop and the largest vegetable crop. Prince Edward Island is famous for its potatoes, but farmers in every province cultivate this starchy root vegetable. Each year, living history farms, museums, and commercial farms across the globe take part in a year on the field. The goal of the project to exchange knowledge on the cultivation of one crop over the centuries and around the world. This year, the project features potatoes. This is a nice mural. to take your picture in front of. This garden patch features edible perennials. Perennials are plants that live for more than 2 years. Take a look around. Can you identify all the fruit, vegetables, and herbs? There's actually signs. So this is a black raspberry. We've got rhubarb, Albion strawberry, chives, Lovage. I've never heard of that. Strong and sturdy stems. In Canada, perennials have to survive tough winters. Rhizomes, underground stems that grow both shoots and roots, help perennials make it through the colder months. Rhizomes store nutrients during the winter and make it possible for plants to reproduce without seeds. Rhizomes are stems, not roots. They grow horizontally underground, unlike roots which grow vertically. Here's a cute little gnome. Okay, so extreme weather caused by climate change may make it difficult to grow crops in the future. Plant breeders are developing new varieties of crops that can survive droughts and floods, as well as new pests and disease. To create these varieties, breeders use the germ plasm stored at the PGRC sites and in other seed banks around the world. Banking on diversity. There are over 115,000 different varieties of plants stored at 3 sites across Canada. Each site focuses on collecting a different group of plants. That's interesting. So, in Saskatoon, Saskatchewan, they have cereal crops, oilseed crops, plants. In Harrow, Ontario, they've got berries and fruit trees. And Fredericton, New Brunswick, potatoes. Right, so why biodiversity? In agriculture, the more biodiversity, the better. When there is diversity in plants and animals, everyone benefits. Each variety or type has their own special qualities. Biodiversity at risk, but some modern farming practices and loss of habitat are putting many plant varieties at risk of extinction. So, to prevent this from happening, the federal government created the Plant Gene Resources of Canada, PGRC, in 1970. Its purpose? To store, study, and share old and new agricultural plants as well as their wild cousins. This is kind of interesting. So PGRC sends samples to the Svalbard Global Seed Vault in Norway, where they are preserved in case of a disaster. So, Plant Gene Resources of Canada, PGRC, receives samples of germ plasm from across the globe. Some samples are new to the collection, others are copies from other seed banks. At PGRC, scientists use them to grow plants to study and to create more samples to share. Researchers and plant breeders from around the world can ask the PGRC to send them samples to build up their collections or to help create new plant varieties. I love this Huge weather vane in the middle. Attention, wind at work. If the blades on our windmill are turning, then the windmill is at work. Farmers use windmills to pump underground water into their animals' water troughs. Farmers also use windmills to pump air into dugouts and troughs. The bubbling air keeps the water free of algae and that can poison livestock. So here is an interesting historic picture. Windmills are a fixture on many Canadian farms, such as this one in Digby County, Nova Scotia in 1920. So windmills convert wind energy into mechanical energy. When the wind blows, it pushes against the windmill's blades, causing the rotor to turn. The rotor then turns the wind shaft. The turning wind shaft forces the pump rod to move up and down. This up and down and reciprocating movement is put to work pumping water and air. Here's the windmill once more. Here's another fun interactive display. So how is it made? In Canada, ethanol is made primarily from the fermentation of corn sugar or wheat starch. Cellulose-based ethanol is made from switchgrass and miscanthus. What is it used for? Biodiesel is used as a motor fuel to power a wide range of vehicles. Pellets are burned to heat homes or farm buildings. Logs are being tested as a supplement to coal in electrical power generating stations. And what is biogas? Biogas is a renewable fuel that is burned. So I won't read them all, but you can come here and there's tons more information for you to read if you so incline. Safe delivery from A to B. So to treat outbreaks of mold or other fungi that might damage crops, farmers usually rely on fungicides. But what if they could prevent these outbreaks in the first place? An Ontario company, Bee Vectoring Technology, BVT, has developed a delivery and protection system that relies on bumblebees and a good fungus to protect crops from fungal diseases. All right, so the last thing I want to show you, so you don't miss it, is a little hidden gem that is right next to, so there's the little play area here, and then right next to the play area, but oh, he left. There was a squirrel. There's a few more animals over here. Well, birds actually, but so here are some chickens. Oh, they're going into their little house. Here's a turkey. I think that is some kind of a duck, but I'm not sure. And in here, there's a couple of rabbits. All right, so that is the end of the tour of the Agricultural Museum here in Ottawa, Ontario, Canada. If you enjoy content about things to do in Canada, especially Ottawa and Ontario, please subscribe to my channel. All right, until next time, happy travels.